So yesterday we had talked about the hill climbing and we had talked about the what are the key regions in the state space diagram of a hill climbing. One is the local maximum. We had seen this diagram. One is the local maximum and the global maximum, right? So we had discussed these regions. What is a local maximum? A local maximum is a state better than its neighbors only, but not the best overall. And what is the global maximum? It is the best overall. What is the objective function? While local maximum objective function value is higher than its nearby states or simply neighboring states, and the global maximum may still exist if we are having a local maximum, right? Then the global maximum is the best state in the state space diagram where the objective function achieves its highest value. As the name is saying, global maximum. So it is basically the best one. This is the optimal solution that the algorithm is seeking. Then the plateau or the flat local maximum. A plateau is a flat region where the neighboring states have the same objective function value, making it difficult for the algorithm to decide on the best direction to move. When all the neighboring states have a same cost to move, right? Then ridge is there. Ridge is the higher region with a slope, which can look like a peak here. We can see in a diagram. So this diagram is there. Or a flat local maximum, we are saying. So it's a flat local maximum. A plateau is a flat region where the neighboring state have the same objective function, and the ridge is the higher region with a slope which can look like a peak, and this may cause the algorithm to stop prematurely missing the better solutions nearby. Then the current state is definitely the initial state or the state. Refer to the algorithm position in the state space diagram during its search for the optimal solution. And then the shoulder is there, is a plateau with an uphill edge, allowing the algorithm to move towards better solution if it continues searching beyond the plateau. So this diagram is important when we are talking about the relation in objective function and the state space when we are talking about the hill climbing, right? So now what are the advantages of a hill climbing? Simply hill climbing is simply simple and ease of implementation is a advantage. Versatility is the advantage. So simplicity and the ease of implementation, hill climbing is simple and initiative algorithm that is easy to understand and implement, making it accessible for developers and researchers alike here. Another advantage is versatility. So what is the versatility? It is having adaptation properties to many different functions or the activities. So versatility is here. The algorithm can be applied to a wide variety of the optimization problems. Variety is there, including those with a large search spaces with the complex conditions, and it is especially useful in the area where the resource allocation, scheduling, and route planning is there. So another, we can see the advantages, efficiency in local optima, right? So hill climbing is often highly efficient at the finding local optima, making it suitable choice for the problem where a good solution is required quickly because it simply compared with its neighboring states. Then the customizability, the algorithm can be modified or can be extended to incorporate additional heuristics or the conditions, allowing to more tailored optimization approach. So these are the advantages. Now, what are the disadvantages, or we can say that what are the challenges in a hill climbing algorithm? So challenging, when we are talking about challenging in form of a local maximum problem, plateau and the ridge. So local maximum problem, in that case, the challenge is there A local maximum occurs when all neighboring states have worse value than the current state. But still, here is the best approach, or the global maximum is not present. Since the hill climbing uses a greedy approach, it just compare it with the neighboring states. It will not move to a worst state. Worst state पे तो नहीं move करेगी, causing the algorithm to terminate even though a better solution may exist further along. Like if the better solution is not present at the neighbor, but it may be present at the further states or the further steps, it will terminate based on the local maximum only. So how to overcome the local maximum? Backtracking technique. What is a backtracking technique? One effective way to overcome the local maximum problem is to use a backtracking by maintaining a list of visiting states. Like the algorithm can backtrack to a previous configuration, explore new paths if it reaches an undesirable state. So it can take the decision from the saved states or the visited states from the history states by performing the backtracking, and can maintain the list and can check for the previous states or the and then explore the new paths if the undesirable result has been achieved in between the algorithm. Now, what is a plateau problem? A plateau is a flat region in a such space where all neighboring states have the same value. So, if the same value will be there, how it will decide whether to move forward, how to move forward. So, this make it difficulty for the algorithm to choose the best direction to move forward. Now, how we can overcome with the plateau here? Random jumps. So, first is the random jumps. To escape the plateau, the algorithm can make a significant jump to a random state far from the current position, and this increases the likelihood of landing in a non-plateau region where the progress can be made. Right? So random jump will be there. Now, what is a ridge problem? Ridge, as a ridge is a region where all movements, all possible directions seems to be lead downwards, where it will not lead to forward, resembling a peak. As a result, the hill climbing algorithm may stop prematurely, as we have discussed, and believing it has reached the optimal solution when in fact better solution can be exist. So how we can overcome the ridge? By the multi-directional search. To overcome a ridge, the algorithm to overcome a ridge, the algorithm can move to the multi-direction. How? The algorithm can apply to move two or more rules that before testing the solution, right? It can move to further directions. This approach allows the algorithm to move in a multiple directions simultaneously, increasing the chance of finding a better path, right? When it is having only the downward situation. So what are the hill climbing challenges solution? We have discussed already. So to mitigate these challenges, various strategies can be employed. First is the random start, right? Random restart. As mentioned, restarting the algorithm from the multiple random states can increase the chance of escaping the local maximum and finding the global optimum solution here. Then the simulated annealing, and this is the more advanced search algorithm inspired by process of annealing in the methodology, and it introduced the probability of accepting worst solution to escape local optima and eventually covered a global solution here. Then the genetic algorithm can be another challenge overcome by the hill climbing. So what is the application where we can use the hill climbing algorithm? We are just closing the hill climbing topic of our yesterday's pathfinding, optimization, game AI, game artificial intelligence, and the machine learning is the application. How the pathfinding? Pathfinding is when we need to find the shortest path between the 2 points from the initial state to the goal state, such as in robotics or a game development. So hill climbing is used in the various AI systems that need to navigate or to find the shortest path between the points, such as in robotics or the game development. Another application is the optimization. Hill climbing can be used for solving the optimization problems where the goal is to maximize or minimize a particular objective function such as scheduling or the resource allocation problems. Then the game. In certain games, AI uses a hill climbing to evaluate and improve its position related to an opponent, right? So it generally move to the upper state. And then the machine learning, hill climbing is sometimes used for hyperparameter tuning, where the algorithm iterates over different set of the hyperparameter to find the best configuration for machine learning model. So it can find the, it can, for the machine learning we are talking about, it work on the hyperparameter tuning. So what is the hyperparameter tuning? What do you understand by the hyperparameter tuning? And what do you understand by the machine learning thinking? Hyperparameter tuning is a kind of a process that finds the best set of the parameters for the machine models, right? And the what is the machine models we are talking about when the machine uses its learning to overcome the problem and seek the solution here. So hyperparameter is to find the best parameter for a machine learning model, or we can say that it's limits the various parameters, and basically hyperparameter help us to get the or explore the insights from the data instead of manually iterating, right? So here we are talking about the iteration in the machine learning. It will work accordingly the algorithm. So hill climbing is a fundamental search technique in the artificial intelligence valued for its simplicity and the efficiency in solving certain optimization problems, as we have discussed in the applications and the advantages. But due to the limitations such as susceptibility to the local optima, where the chances for the global optima or maximum is not there, it is often combined with the other techniques also, like the random restarts or the simulated annealing to enhance its performance. And broad in the broader AI escape, hill climbing remains an essential tool for heuristic problem solving and the optimization task here. So where we have studied about the hill climbing in heuristic search technique.